Hello and welcome to the SAFI Learning Center. The following tutorial will demonstrate how to apply the vessel motion loading to an existing structure. The following is a simple example where we will apply the vessel motion loading to an existing structure. Here are 4 different columns. Each of them have a 50 kN load at their top. We will apply the vessel motion on this structure so the acceleration will be equal to the existing weight. We will apply many different acceleration cases. The first we will see here is an acceleration around Z. With a given period creating horizontal accelerations and rotational accelerations equal to the weight. Let's see how it is defined. First, before specifying any vessel motion accelerations, we have to create basic loads corresponding to a vessel motion load type, and you have to define their names. Here, we created many accelerations along X, along Z, and along Y, corresponding to the weight acceleration. All of them are applied in the positive vessel motion convention in SAFI. So, the first thing we have to do is specify what is the weight of the structure. In this structure, we only have one basic load including 100% of the weight. If there is additional weight, you just have to use the down arrow key of the keyboard to create new lines, and you can select them with their load factor. Then, you can create an acceleration around Z using the period and amplitude option. You would specify a period of 7.6 seconds with 15 degrees amplitude. We can see that the center of rotation of the vessel is far below the structure. We can also create horizontal accelerations directly using a translational acceleration motion with a period and amplitude. Or, you could also specify an acceleration directly as an angular acceleration in radians per square seconds. All of them are creating forces along X, or you can directly specify an acceleration along X. So, all of these accelerations create positive forces in the structure. We did create many of these cases. You can edit the loads directly from the tables if you have many to create. For this example, we will concentrate on the force along X. So, let's go ahead and run the analysis now. For sure, there was also load combinations created accordingly. Each load combination is including only one basic load at a time. Let's go ahead and run the analysis. One interesting thing you can have a look at in the results is the reaction summary. The reaction summary is equal to the sum of the force applied to the structure, so it is the sum of the reactions. Here we have the dead weight of 200 kilonewtons, and we also applied those horizontal accelerations with given values corresponding to the weight. We can see here the given reactions are equal to the same as the force. The same would apply with the force around Z or the vertical accelerations as well. When running the vessel motion on a structure, you can also add the effect of the self-weight corresponding to the defined mass to a vessel motion load. For example, like this one, we have the structure inclined. You have to remember that in an inclined structure, the gravity will stay as a vertical loading. So, as we analyze your structure as a vertical structure, it is equivalent as having gravity as an inclined load. You could specify here the ratio of the vertical weight you want to include, or the ratio of the horizontal weight. In the code, there is a clause that specifies where you need to increase the horizontal component of the weight and can do so by 20%. You could do that directly from here by defining the horizontal component. If you need to include the vertical weight directly inside the vessel motion, you will put here a factor of 1. That means, if you include those here, they will be directly inside the vessel motion. When you will create a load combination, you will not have to add the weight another time since the weight has already been included in the vessel motion. I hope you enjoyed this video. For more videos and information, please visit our website at www.safi.com.